everyone, look at us. We're here. We're live. Welcome to our meetup. So this is our first MySQL meetup. Hopefully you're joining us on Twitch or YouTube. So if not, you can watch the recording here. We're, gonna do these every week, a different technology. Once a month, we're gonna have MySQL, then we're gonna have Postgres, we're gonna have a few other things. So Marcos is going to join us, but I think Marcos might have got stuck helping a customer and trying to solve some issues. So he's going to be a little bit late. So Nando has joined us. He's one of our
Hello, everyone.
Speakers. And, if you want to give us a wave over in chat, we should be able to see you on screen and say howdy ho. So hopefully, you guys are all out there watching, the stream out there. Now, interestingly enough, I actually, I had an interesting weekend, Nando. I've been playing around with dashboards and stuff with PMM and MySQL and Postgres.
Okay.
And so this weekend, my server stopped working. Hey, Wayne, how are you? Glad to see you. So my machine, I've been running all kinds of crazy load, and so I'm like, oh my God, what happened? And so I spent about an hour trying to figure it out. I left everything as the default location for MySQL and didn't rotate the slow logs. And so it filled up the disk. And so everything just stopped working. And so it took me about an hour to figure out, like, I'm just an idiot.
Well, it happens all the time, Matt.
It was so easy, right? Like, how could you, like, yeah. So a reminder for those using PMM or the slow query log, rotate your logs, especially if you have heavy workload. I was just testing, so it didn't cause me any, big grief, but it was something that I'm like, wait a minute, how come I can't, run this sweet benchmark anymore? So
those are the things that always come back and we see happening again and again since forever, Matt. You see that alerting on the disk space is still very useful everywhere.
Well, I didn't set any of that up yet, because I'm just trying to do some benchmarks and some tests and just trying to move things a little forward. Oh, and guess what? Our second guest of the day has showed up. Oh, here he is. It is Marcos.
Hello, Master Marcos.
He's trying to get his volume. I don't think he realizes that he is live, and so we're going to see what kind of embarrassing things Marcos does. No, he's just going to freeze.
Yeah, sorry, I had
some technical difficulties. That's okay. You missed my story about me filling up my disk space on my test server and making everything stall, and so I couldn't figure it out. So I was just lamenting. Oh, and look, Wayne says, Marco, that Marcos, you've helped him on so many tickets, so it's good to see his face. Do you recognize Wayne?
Absolutely, I do. Yes. Right. And thanks for joining us in this meetup, and glad to help you.
That's good. So just so everybody's aware, this is the first one of these, and so we want to do these on a regular basis. We figure we'll get a few folks here, and we're going to grow over time as the reputation of this, gets better and better. We'll get more and more people, but we're always going to be looking for people who are interested to share some interesting topics. They want to come out, share with us a few different things. We'd love to see you out here, and you can present here, and talk. But this is nothing that's scripted, so we want to hear from you. So feel free to put it in to YouTube chat or in Discord. You can have that pop in, or Twitch. All of them should pop up here, and we should be able to follow along. So if you have a question or you want us to dig into something, feel free. But we did start with a couple of interesting topics. And I heard Marcos demanded that Nando go first, so that's okay. So since Marcos gets what Marcos wants.
I think he's ready. Look at he and his beer. I think he's ready.
Oh yeah, yes. Hi Mike, how are you? Mike Pate is joining us. If you build it, they will come. So that's good. So Marcos, are you ready?
I sort
Are you
of
ready? Are you set?
I guess I'm
so
ready.
Marcos,
Yes.
So Marcos, you're going to talk to us. You're going to tell us how to actually tune systems the right way, right? Is that what you're talking about?
Yeah, no, not precisely. I'm not going to talk about tuning the database, because that's not how you really get the best performance out of your database.
Oh.
I mean,
okay, how do you get focused performance?
You get good performance.
So tell me, how do you?
If you schema properly, and good performance if you do your queries properly. That is used to any database. The database is just as good as the queries we send to them. And that is really what most developers miss when they are working with the database, is they forget that the database, the only work the database does is running queries. In reality, the database, you have a declarative language. It's not an imperative language. SQL is declarative. You tell, hey, I want you to give me all the users who are called Marcos and order them by the last name. And the database will know how to actually fetch the data. It has many ways to. It could choose, to access the data through the primary key, or it could access the data through it could choose to sort the data on disk, or it could sort the data in memory. So it can end up with a different exam, right? And
yeah,
well, what we have to do is actually help the database create better plans. That is the key to database performance. Proper schema design and proper query design, and of course the right database for the job. You want to manage 10 terabytes with, it's going to be painful. That's like a reality. There's little that you can do with 10 terabytes. So once you more easily write than read, and most of the pain comes when we are trying to read. So the number one thing, proper schema design with indexing, and that is, I think what it's hard for developers, and which it's funny, because what is an index? It's a B+3, and developers, I'm sure most of them, the B+3 is and how it works, but they forget that.
Is it like the database design itself is almost a lost art, because everyone just kind of throws garbage in, garbage out now. I mean, like, nobody wants to think about that. And I mean, a lot of new databases are trying to mitigate, like, even having to think about a schema. So they're trying to build in logic in order to prevent it from happening.
Yeah, but in the end, the database cannot predict what are going to be the access patterns for the data. But you the application designer, you know beforehand how you're going to access the data. Like, am I going to be sorting by the last name? Then I have to help the database achieve that sorting. Like, I have to make that sort easier for the database. And how do you do it? With an index. And indexing is key to, I would say, 80% of better performance. Like, customers come to support, they have performance issues, and more than half of those issues, they are due to bad queries. And I would say more than
really that much, 50% potentially.
Yeah, because it's always the ultimate answer, right? Like, so the database is slow. Why? Oh, because the disk is saturated. Why is it saturated? Oh, because it's reading pages from disk all time. Why is it reading pages from disk all time? Oh, because the buffer pool is too small. Too many rows that actually did to satisfy the query, and that they are being read just you didn't add an index. And so in the end, it's not that the disk is slow or that the buffer pool is too small. It's that the queries are reading inordinate and unnecessary amount of rows. So indexing is really, really the core of better performance. Proper indexing, not over-indexing. Over-indexing can kill your performance. But proper indexing and good query design and good access patterns are the center for improving your performance. So,
Nando, you were going to say something. What were you were going to chime in there?
No. It's just that I think another way to say it, what Marcos is explaining is this: you are trying to get a single result or a handful of results out of your table with a query, right? But if your query, if MySQL, in order to get those results, it needs to fetch over 2,000 or more rows, right? It needs to fetch that from the database in order to sort those and then aggregate with other queries in order to get those handful of results. Think about the amount of work that is required. It is going to work, right? It is going to work, but that is an extraordinary amount of extra work that could be avoided if you had the schema optimized or the query optimizer for the schema you have. I think that's an excellent point, really. Yeah.
And it's funny. I was thinking about this last night. I woke up at 3 a.m. and I think about database things. That's weird, right? Is that weird? Does anybody else do that? I don't know. Does anybody else do that? I do that. But Marcos doesn't, and I feel very disappointed there. Yeah. So so I was thinking about this in the context of I'm thinking about writing an article on sharding and the necessity and the reasons why. And there's a lot of sharding is an old technique. I mean, it's been around for ages, but realistically, all databases really only have two constraints. And my theory, or what I was thinking, is really you're talking about either it's a throughput issue or it's a concurrency issue. And when you talk about indexes, it's kind of hitting both concurrency and throughput, because as you hit disk, you're limiting the number of people who can access that disk at once, and you're also definitely slowing things down. So you're really it's all about optimizing throughput and concurrency. And as you start to look at the different techniques on performance tuning, optimization, it all boils down to which of those knobs do you turn and how much, and which methods do you use to turn them. Am I right or wrong? I don't know. Or is it just a 3 a.m. thing?
There's this universal scalability law from what's this guy from Guerrilla capacity planning? What's his name?
I
forget.
Jeremy Cole?
No.
You've proven scaling? No, you were.
The book is called Guerrilla Capacity Planning.
Oh, okay.
And there is a universal scalability law. Actually, Baron contributed to
Neil Gunther.
Neil Gunther, that's the guy. And basically, concurrency is one of the denominators in the equation that defines the law, right? And the more concurrency, the more contention there will be, and that actually increases response times, right? Like, who cares about replying to you very quickly? Nobody, right? That's boring databases are good databases, but when the response time is high, then that's when people starts complaining about the database. And yeah, if you have concurrency, if we only work and we all want to eat from the same plate, then like we have to wait, and that wait time translates to slow queries. So the concurrency in a system, it's certainly a defining part of the performance. But if your residence time database is 1 millisecond, then you can have more queries. I mean, concurrency is the effect of having queries running in parallel, right? And that they will compete for the resources needed to read the rows or sort the rows or do whatever. So the longer the query takes, the more likely it's going to have other concurrent queries running along. So to reduce it, you have to shrink the times for it. There is no magic bullet that will alleviate contention. Sometimes we can split a mutex. Sometimes we can avoid by reading the isolation requirements. But there is no magical solution to reading from disk. If we all want to read from disk, that's going to be the mistake. So what we have to do is properly index so we avoid reading so much from disk.
Yeah, so, you said something interesting, and I pinned it here. That no one really cares about query time, right? It's about the response time of the application, and obviously the components of that application, which are reading from disk. It's the query response time. It's the things that are missing indexes. It's the really crappy queries. Those are the things that are. You can get that live on the air if you want. That's fine. I mean, we love it. You never know who's going to call in. So is that Wayne? It's Wayne calling in. It's Wayne calling into you to get on the show. He wants to ask you a question, I'm sure.
Yes, emergency. Open a ticket, Wayne.
Just open a ticket. But no, it is an interesting concept, right? Because so much of how well an application performs is based on that initial design and that initial setup, and it really sets everything up for the future. And this is where I think that for a lot of us, when we talk about whether it's the cloud or these other technologies that are all coming out to make things easier, they don't always solve the scalability issue, because you didn't design it up front, you didn't fix the issues up front that were going to cause you problems. So you would just end up having to throw more and more resources at it, which does alleviate the the throughput issue and the concurrency issue somewhat, but you eventually run out of resources that you can up.
And think about this, Matt. You have your application, your development team working on your application, right? And the team tests it, and it works. Right? It just works, and the queries are running fast because the response time is fast. And then you try and you change the test environment and try to put it on some load and some concurrency, right? And still are reasonably fast, so the response time is there. But not always those tests that you do in staging, they really reproduce what you are going to get in production when you launch that application, or even more particularly, they won't match what you are going to see once your application becomes really popular, right? So it's still interesting to review the schema and that not only focus on the response time for your tests, but really what is it that the query is doing, how much work MySQL is having to do to get the results you are asking from it.
Yeah, and I mean, it's interesting because what starts off as fast can quickly become slow, right?
Right.
I mean, and that's really the crux to the issue is slow becomes, or fast becomes slow very quickly when production workload happens. Marcos wants to say something. I see it.
Data has organic growth, and like what 6 months ago was a perfectly fine query now, and it was a scanning table, like a table scan. It was scanning 1,000 rows. 6 months later, it's scanning 2 million rows, and now it's taking 2 seconds to go. And that's just organic growth. Change it in the database, change it in the source code, all the same.
Well, the amount of data just change it. Yeah, it just grow. Yeah. That's another point.
So, and Ryan Lowe, we used to have a talk that throwing money at the problem. And basically, we try to find the limits for both vertically, by just adding more resources, faster disk, more memory, more CPUs. And there are queries that they will simply not scale, that no matter what hardware you use, they will not scale because for example, if you do insert select, and the select will do a full table scan, and the table, it's a popular table that also gets updates or also gets deletes, then all those updates and deletes are going to be blocked. And there's no way around it. That fast your hardware is. It's just that the access pattern, it's a bad access pattern. So what you can information to disk first, doing insert select. I don't know. We could try to find solutions, find workarounds. But throwing money at the problem, like adding more resources, doesn't solve it. And it will not solve other queries as well. So that I think it's important to consider that the database, it's as the work we put on it, and the difference between a database that runs super fast and has good response times to every, it's and a database that responds poorly. It's again mostly a difference in the design of the schema and in the choice of access patterns and how we design the queries, right? But the example, another classical example is using as a queue, right? Trying to use as a queue processor, and we know it fails miserably due to locking issues. And again, that's
so Marcos, do you think that largely at small volumes, most databases' performance are fairly similar? Like when you've got a reasonable workload, like it's pretty small, choosing one database over another matters very little.
Oh yeah. If you have a few thousand rows and your operations, that doesn't matter, right? Like if it's a few thousand rows, I don't think the database is gonna be pushed to its limits, right? And that all operations are gonna finish fast enough that even the contention and the concurrency problems are still gonna be mostly invisible, because it will be hidden by the fact that operations complete fast enough. So your response times are gonna be fine, not because there is no contention, or not because it's not creating horrible temporary tables on disk, but just because the temporary tables are gonna be small, or the table scan is gonna complete quickly. So
if everything's in memory, then most databases are pretty fast. And I mean, the difference between, the 1 millisecond and half a millisecond might not be noticed if you've got, only like 20 users. So
yeah, but you know what, Matt? With 20 users, that is right. But even if you have a very small data set, but extremely high concurrency and a bunch of connections just opening and closing, opening and closing, opening and closing, this is a point where different databases perform differently because of the design. So there are weaknesses and strengths on the characteristics of database management system, and then we can compare those. right?
Yeah, I mean, it's the concurrency versus throughput, right? I mean, that's really what it is.
Yeah, well, it does come down to that.
Yeah.
But
Yeah,
I have just an observation to make on what we are discussing, because what Marcos is saying is absolutely the case, right? You should give proper importance to the schema and the query optimization. It comes to some situations where we have seen customers working with third-party applications where they can't really just change the queries. There is still the chance of trying to improve the schema, right? Because the schema is hosted by the database, so you can add an index that could make a complete difference to the execution plan. But also, it is possible for those very long queries that require more time to execute, and due to high concurrency, you just see several requests just piling up inside the storage engine, right? InnoDB, for instance, it allows you to limit the amount of queries that it will process at a given a single time, right? So you actually, there is a setting where you can limit how many requests are being processed at the same time. Why is this an interesting proposition? Because then those queries are not competing with everybody else for the resources, and they are giving more resources to complete, and then they just complete and go away, right? So you can process other queries. There is still a very significant space for server tuning, right, Marcos, in function of the workload you are dealing with.
Yeah, you can tune the database, and there will be, like, if you have a very heavy write workload, then tuning flashing and properly dimensioning the redo logs and properly dimensioning the log buffer, stuff like that. Like, it could improve, and we have helped customers improve replication speed by properly tuning flashing and making writes more agile, right? Like more lean. But in the end, again, there is always a limit for the concurrency, right? Like that's we know that we can add more threads up to a point where things stop scaling linearly, and actually they have negative scalability, right? Because the concurrency itself will hurt the performance. And you were saying that sometimes we don't have access to the third-party application to change the queries, but we can use the query rewrite plugin in MySQL 5.7 and newer, or we could use ProxySQL as a middle layer.
That's also true. Yeah.
For Postgres, I know there is none for MongoDB, but for MySQL, which still holds as the most popular open source database, two options to actually rewrite on our side without intervention from the developers. So,
well, but not everything needs a complete rewrite, though, right? And I think that's what, Nando, you were saying is you can add indexes. Now you've got functional indexes, you've got generated columns that you can do some things with. You can hide columns, so if the application is doing a select star and doesn't expect that extra column, you can hide it and add a column even if you can't. Like, there's little tricks you can deploy to get around some of those limitations. And I think more and more databases are kind of like realizing that there might not be a complete control, so they're trying to give you more of those features.
Yeah, and like you said, hiding an index or hiding a column help change the behavior of a query and make it work when you don't have access to a developer that is willing to change the query itself, the original query itself. Again, I think the big takeaway is that, right? It's like concurrency is limited. There is no eternal growth. Resources in the physical resources, we have a customer who has a machine with 144 CPU cores and 4 terabytes of RAM.
Wow, and one machine. This is one machine. This is not a cluster. This is one machine.
Yeah, this is one machine. This is one machine. it runs a single MySQL instance with a 3.4 terabytes buffer pool. And
how many cores are those? Are those 32 core machines or CPUs?
It's 36, right?
36.
36
Wow.
cores, 72 threads, 144 in the two NUMA nodes.
I mean, like,
So,
you know, I remember when I had my, you know, like, look, I got 2 cores. Woohoo! You know, this is awesome. This is stellar performance. Me and my 2 cores and my 4 gigabytes of memory. Woohoo! This is gonna rock. You know,
well,
now look at where we are.
but this guy, you know, he has 4 terabytes of RAM, but his database is like 9 terabytes. So,
yeah,
you know, still doesn't fit. And data keeps growing and growing and growing and growing.
Yeah.
So,
I mean, I'm curious what other people are have in their data centers. I know that I have seen, like, some people. I personally experienced this on occasion where, you know, you've got someone who has like a 200 megabyte database, and they've got like this, you know, 1 terabyte worth of memory, you know, 64 core box, and you're like, what the heck are you doing? I just want to have it in case it goes wild, right? I just want to have that in case it goes crazy.
Yeah. Well, and you know, again, the fact, you know, there is an interesting thing that I was thinking the other day, and it's related to the ever-growing database, and it's you know, like we tend to not be very careful with database growth. You know, people just say, oh, I'm just going to store it, you know, like, and they keep storing data, and later, months later, years later, people, you know, someone comes and says, what is this table for? Or where is this table used? And actually nobody's reading that data, and it's been saved, indexed, and backed up for months, right? And like nobody's using it. And the other is that they don't summarize data. Like they just keep archiving data in raw format without making summaries and aggregating data for later consumption. So every time you have to read the data, you have to read every detail. And you know, with the chip shortage we are undergoing, I was thinking that it might be a great time to have people rethink their behavior of careless, you know, microservices that are forgotten in a cluster, and they are just running there and nobody's using. And
wait, are you suggesting people clean up their crap?
Yeah, that basically, I think it's, you know, considering the chip shortage and seeing that CPUs and memory prices are hiking, I believe it's a good idea. You know, I do think it's a good time to consider a cleanup. And the savings can be massive. You know, like the other day I was showing a customer how much money they can save in AWS by just optimizing their queries to, you know, stop that they don't read and stop reading data that nobody, you know what they have? They have SQL calc func rows, where you do select SQL calcs from my table limit 20, but if the query will have returned 1 million rows, it still scans the 1 million rows to only return 20. Well, they were using that everywhere. And
really? Oh.
Yeah, so, you know, like there was no buffer pool that would be enough. And every thread was reading 6 million rows. Each thread for we're doing, like they were reading 6 million rows, 500,000 rows, you know, just to return 20, 40. And they could save thousands of dollars. Like literally, we did the numbers, and it was in, you know, $5,000–6,000 per month. Which, you know, it doesn't seem like much, but you know, it was just a single product. Not all of their databases. This was just a single product with a single database. And that kind of savings, how they, again, like the shortage of silicon, you know, it's a reality. and it will make prices go up. So using those resources you have in a smarter way might be in your best interest.
So two suggestions that pop to mind based on this conversation, and I'm interested in your opinion and those who are watching live. So number one, so should we get stickers or T-shirts that say, like clean up your crap, friends don't let friends keep microservices on forever? Do you think we should do that? That's kind of what it sounds like, right? I think I would put that on my laptop. That would be cool. But I think that we need to advocate for DBAs and SREs that they should get like 10% of whatever they save off of cloud bills when they optimize. So like everywhere, everyone should be like, hey, look, 5,000-6,000 a month off of this one server. Well, hell, that's $500-600 into the DBA's pocket or that.
And you know where you should start for people watching this. You start by making sure you enable the slow query log, right? Have it enabled and start collecting your slow queries. And then you can use one of our tools there, the PT Query Digest from the Percona Toolkit, and start looking at the trends and see what are the top slow queries you have, right? Usually those top slow queries, they are consuming they are responsible for 20-30% of the execution time, right? So you start by trying to optimize those queries. So there's an easy way to go, right? And if you are Percona customers, you just open a ticket and we can help you with those.
Absolutely. And I was also it's a funny thing, but that we, how in the European community you can each company has carbon credits, right? Like you can only produce so much carbon footprint, and if you have negative carbon footprint, you can sell your carbon credits to other companies. So if we optimize a query, and we are reducing the amount of energy the same software is consuming, because that's what you get when you optimize a query, right? Like you can use less servers and shrink your carbon footprint because servers require. And we could have, Percona could accumulate all the carbon credits, because it will be. I mean, I would love to have that counter. How much carbon emissions we have saved by optimize? I would love to have.
If you can figure it out, we'll put it in PMM. That'll be our mission. But
I think we should summon Yves Trudeau, Matt. We should summon Yves Trudeau to work on this because he's gonna love it.
Yes,
this is dear to his heart. So
what does everybody think? Should we get a carbon footprint offset? By the way, Wayne says he has much love for the toolkit, which we appreciate, Wayne.
Thanks.
Very nice, very nice. But no, I think we can do this. I think we can figure this out. So we'll get on that, and maybe by the next time around for the MySQL meetup, we'll have something that we can show. What do you think?
Yeah, if we could figure out what is the carbon footprint for a 1 second worth of platinum Xeon, off the shelf average high-end server, right? Like what we see in databases nowadays. That would be super, super interesting, because if you have the per second, then you can say, oh, if this query was running in 60 seconds and now it's running 0.5 seconds, really, calculate the footprint. That would be.
And there are estimations for that. I remember seeing this 10 years ago. So there certainly is.
Yeah. I mean, I can see that. Like, if you can do it based on power, it looks like, 1 unit of carbon is equivalent to, So I mean, like, you can find it. It does exist out there. So yes, there you go. So we can do this. So let's get that for the next PMM, or we'll either do that for the PMM meetup that we have in a few weeks, or the MySQL meetup. So we'll get on that as well. But you know, as we talk about this stuff, you know, I'm sure people are going like, you know, we're all over the place here. You know, Danielle's pinging me going like, wasn't somebody going to show a presentation?
We're still focused on query optimization, which again, in my humble, it's the only way to truly have a scalable database. And you know, it's the difference again between a slow database and a fast database. Nobody is looking at because it's always giving you good response times. Is proper schema.
It is the only way, or is the proper way, Marcos?
Well, it's I wouldn't say it's the only way, because again, there are some workloads that you cannot scale horizontally, right? Like you cannot start sending critical reads to your replica. Well, if you have PXE, you can. But, you know, insert workload, update workloads, you know, which also require to find the rows it has to update first. If not properly indexed, those will never scale.
Okay,
and those
that's fair. Yeah. Yeah.
So in all honesty, proper indexing, it's, you know, a fundamental part of this. And you know, now that you mentioned it, Yves Trudeau, I always remember something Yves taught me years ago, which is related to Skyline, and is, you know, we always see customers using big int, which is 8 bytes for their primary.
Yeah.
Yves give me a good comparison point, which is a big int is enough to count the ants on the earth. You can count all the ants in the earth with a big int, and you still have some left over. So when you're designing your schema, you can ask yourself, am I really gonna use all those bytes that I'm asking for the database, or perhaps, you know, 4 bytes will. So sometimes it's
from a developer perspective, nobody wants to byte count anymore. I mean, come on, that's old school, right? Like, who wants to think about bytes? I mean, like, it adds up. I will grant you, but nobody wants to think about it.
Yeah, that's a movement that is coming. If you look at, I'm not really looking into development that much, but I remember with Ruby on Rails, which is a framework, right? You would have on MySQL, it created with int for primary keys, and nowadays it is big int. So there you go, Matt. People don't want to worry about. But I do think it's maybe exaggeration, right? Because like Marcos said, the actual use cases where you are going to make use of big int are not the majority. They're certainly not. But well, I do understand your point, Matt.
Well, so it's interesting. So Yves used that before, and he's like, yeah, you know, there's no use case ever for it. And then he went to this satellite company that does GPS satellites and micro satellites, and they do like coordinate positioning, and they actually needed the big int. So he actually found a use case that actually did require it. But I wanted to point out, Fernando, when you said the words Ruby on Rails, Marcos's face like cringed in a way that I like, even in his little fuzzy camera, you know, that he's got, I totally
I know why,
because he was having some bad like memories. He was having some bad flashbacks.
Tell us about those dreams, Marcos.
Those were the dreams. I wake up at 3 a.m. to think about like sharding and scalability. You wake up to, you know, Ruby on Rails.
Basically, man, the amount of times we have seen Rails failing to scale because all the metadata it pulls, the ORM pulls from the database show fields 800 times per second, and obviously it didn't scale. And that's another advice for making MySQL faster. What is the fastest query you can run? Is the query that never runs, right? Like the query you don't run is the fastest one. If you can keep a cache, then that's the fastest query. And that it's again something that Proxy SQL provides, and which can make a night and day difference. right? In this case, simple and so useful for the show fields example. And we have that they couldn't believe it, right? Like they were like, how could 800 operations kill the database? Well, the database has certain structures that are governed by a mutex, and concurrent access to the mutex, it's problematic, and even few hundred operations per second can make it painful. And we have Alex as
Alex,
hello, guys.
yes, welcome, Alex. We're glad to have you here, and we have a question. Hello, guys. Advise me. Getting lack of disk space on MySQL server. Can't add physical disks, but have another empty server. How do I shard some of the databases to there so I don't break all the dependencies? Ooh, I saw Nando there, kind of like, ooh, he took a little deep breath.
Alex, this is so application dependent. There is no universal sharding tool. There are sharding frameworks like Vitesse, but you don't just say, oh, let's shard this table. And there's a mechanism like there is in MongoDB where the config server keeps track of where the pieces of the table are. In MySQL, there is no such mechanism to do it. So it's a very per application thing. Normally, you can reclaim disk right there where you are. And like we were saying before, try to find unused indexes with PT duplicate key checker, and using sys schema, there is a function or a view that shows unused indexes. And then you could also try to find out data types which are excessively large for your needs. Like we were saying a second ago, if you have many primary keys that are big int, many of those, you most likely can make them an int. While the 4 bytes difference at first don't seem like much, on a few million rows, they start to add up. But not only that, because every secondary key has a copy of the primary key. If you have, say, 5 indexes on the table, you are saving 24 bytes, not only 4. And again, when you start adding millions of rows, they start taking up space. And so improving on the data types, dropping duplicate indexes, running optimized on tables that have got many deletes, all those can help.
This is an important point, that one. You might have tables that have grown very large over time, and then the actual amount of data now it's much less, but the table space file just grow up big, right? So if Marcos said, if you identify those tables and you rebuild them, they are going to be optimized and come over much smaller, right? Just the size they should actually have. But you do need to have enough disk space to make a temporary copy of those tables when you are doing this operation. But maybe this one is something to really look at, because it's a kind of easy solution.
Yeah, and then back when I was in consulting, way back, but I've heard that this is pretty consistent. Those space savings, whether it's data types or just making small changes, 30-40% decrease in disk space is not uncommon. I mean, that's a pretty significant disk savings.
Yep. And well, the last option, Alex, will be archive data. If you have tables that are growing and growing, but the old data never changes, you could probably data into ISAM packet table that will allow you to keep the data accessible, and that will be much more space efficient. InnoDB has a huge overhead in disk space. It has humongous right.
Yeah, and I mean, there's also MyRocks, which also can help pack bytes as well. So there are options with alternative storage engines, but one of the things you could also do is you mentioned some of the data. It might not necessarily be needed by the full application. Some of those, the data is often just there for reporting. So you mentioned you have an empty server. It's possible to have your empty server have your archive data or full data sets of some tables and shrink other things. So one of the other things we've also seen is, you might have a year's worth of data on your primary server, and then on your secondary servers, you might have more than a year. So
yeah,
that's another.
And there's another tool from the Percona toolkit for this, which is PT Archiver, which can facilitate the archiving of data from one server to the other, for instance.
Yeah, great. And so Wayne has a question. So Wayne, wants to know that he's working with a new cluster using Proxy SQL and Orchestrator. Has a question on replication. I have 4 tables unique to each server. I want to filter out those 4 tables.
Yeah. So I'm not sure. Are those 4 servers working in basic replication, like a circular replication? I mean, you have 4 masters, and each of them has a unique
primaries.
Yeah, thank you.
I think that's the scenario. Yeah, I think he can explain further to us, but I think he's talking about having 4 masters, each with one different table that he wants to unify those together. Is that right, Wayne? And
he says that it is a primary replica, so it is primary replica there. We can put the full chat on, so we can see that come through as it happens.
I think you can simply use built-in 1 master, 3 replicas. Okay, so and each of them has a unique table, and you want to filter out. So on the replicas, you don't want changes in those tables to go to the binary log, and on the primary, you don't want changes to that one table primary to go to binary log. The only option is to do binlog do db or
skip table.
Yeah,
it's a yeah.
But I don't think the built-in replication filters are the only option.
Yeah, because I mean, it's not going to go through proxy at all for those, right?
Yeah, but he wants to filter. He doesn't want to have the event for the tables in the binlog. And no matter what you do in the proxy, if you send the write to the server, to any of the servers, at one point there will be.
You're going to have to do the replicate ignore table, I think, but that'll still show up there, right? Yeah.
Yeah. But anyway, you are more than entitled to open that. Glad to join you on a call and give you more and give better advice with more details. And Alex said, yeah, cool, thanks. I made archives for all time, prepare queries to delete some data. All right. These writes will go only to its server. Yeah, you need to skip it with a bin on the writer side. So, damn it, I never,
It's replicate ignore table. It's replicate ignore table, right?
Yeah. Yeah. No, but that's on the replica. He wants to never.
But he is writing directly to the replicas. I think that's the point, Wayne. You can clarify, but I think you are writing to those replicas besides the replication flow that is coming from the primary, right? So there are unique tables in each of the replicas that are being written directly, and you want to unify this data. Yeah. Okay. You see, the only thing I can think about is a multi-source replication where you are going to have a 3rd level replica below your replicas, which will be replicating each from each of those 3 replicas on the 2nd level, and you are going to be only replicating those unique tables from the replicas into that 3rd level replica.
But you could do you could do a poor man's replication, right? With proxy SQL, where any writes to those servers, you just redirect to the other servers.
Yeah, no, but what he wants, you know, Wayne, the way to do what you want to achieve is make that table live in a separate database, and then use binlog ignore db, and then you can ignore the database that only holds that table, and that will prevent it from going to the binlog. So you will have to have the database table in a separate database. You could have a view in another database that is a one-to-one, bypass to this table on the other database. So it wouldn't change the reads formation. I cannot think of another way.
Okay. And Alex does have another question, and he popped in there. Wayne's going to open up a ticket. But Alex, one more question, more abstract. Which advantages and disadvantages between keeping MySQL on hardware, so bare metal, versus containers like Docker? What are you dockering? Are you like? I think Marcos is very excited about the Docker thing.
No. I was going to say that one of the big advantages of keeping my SQL Server on hardware is that you're going to make no.
Marcos.
The disadvantage of keeping the server in hardware, the only disadvantage it has is that hardware is slow to provision, and it's once you ordered that machine in the data center, or that you rented the machine, you are stuck to that box for some time, right? Like, heavily depends on how your company deals with hardware. But
it's not just hardware provisioning, though, right? It's also the setup of the database and making sure that it's consistent across multiple nodes. I mean, like, there are economies of scale that you get by using orchestration tools. Whether that's, I mean, there's other things other than Docker, right? So having a container image, if you're running an operator for Kubernetes, or if you've got Ansible scripts or whatever that set up consistent images and consistent software and configs, you get those advantages as well. So it's not just hardware.
No. What I was saying is that the main disadvantage of hardware, right, is that it's like you're stuck to it. In a sense, you're stuck to it, right? Like, once you have the database running on some hardware, like, ordering more hardware in place and setting up the database, it's difficult. Yeah. Again, okay. It all depends on how you will provision the containers, because the containers also have to run on some hardware.
I think, and I also think that another one to consider is how many MySQL servers you're going to be.
Yeah, that's a point. Yeah.
If it's just like one instance. If it's you need 12, every microservice wants some database.
We go again about the microservices, right? Are you going to have a really small database for a particular service, and you want to segregate to those, or is it really a big database that is going to require a dedicated server just to to have enough hardware resources? I think that's also important thing to consider.
Great, Wayne, thanks for showing up. Appreciate it. We'll see you next time. We got one more question. This is the last question we'll handle. So can we save the password for encrypted keyring file password variable encrypted in the configuration file?
Unfortunately, I don't think that's possible.
Yeah.
No.
You'd have to store it in another vault somewhere if you wanted to do that.
You will have, what we normally advise is to have a encrypted volume that you mount when you database, and you then unmount it. So the ring is protected, and
We were discussing this topic last week about Postgres, but it also fits here. And people were discussing about keeping the password on a file in the file system, or even keeping the password as environment variable, right? Which, if you do have a root access to the machine, you are going to be able to see it inside the /proc, right? And another thing that came up with is that you can kind of secure the file a little bit more with SE Linux and or AppArmor in Debian, Ubuntu, right? It is also possible to do this and restrict the access besides the actual file permissions that you can set, right? So I would suggest have a look at this, because it is possible to restrict even more who can access the file. Could be just the MySQL process that is running that can access it. But I haven't tested this myself. Theoretically, it is obviously possible.
All right.
It's a great topic for another still, Matt.
Oh, as per compliance and CIA guidelines, GSO team was requesting not to store any password and configuration file in plain text format. So yeah. I mean, that's So the options are.
But again, the way most customers in Percona have solved it is actually using Vault instead of a keyring file. The keyring file, I don't think it's compliant. I think you need to use Vault or another key management system.
HashiCorp Vault. Yeah.
Marcos, Nando, thank you for coming out. I know we scheduled an hour. We're a little bit over. I'm going to be mindful of your guys' time because you guys are really busy. You're out there helping customers. We're glad you stopped by to help out some folks. I know, Nando, you had a presentation just in case we didn't have stuff to talk about. It turns out we had more than enough stuff to talk about. But if you want to come back and give that presentation, I would love to see it. And
absolutely,
got it done. We're glad everybody enjoyed, and we hope to see you next week at our Postgres, following week at Mongo, week after that's PMM, and then we're back to MySQL again, and maybe we can coerce Marcos and Nando to join us again on one of those calls. I've been talking to a few of our old buddies at different companies, so we'll see if we can get them here too.
I'll be
nice. Thank you.
Again, and again, invite customers to bring their PMMs and do some diagnostics. Like
you got to fix my PMM. My PMM ran out of space this weekend. My PMM ran out of space, so you need to fix mine first.
I'll fix yours. But I want to diagnose, not fix PMMs.
You can diagnose my performance issues. I purposely made bad queries for this. So you can try and fix my bad queries. Yeah.
All
right. Thank you, everybody. We appreciate it. Don't forget to check us out on YouTube. Subscribe. Hit the subscribe button. We love it that you subscribe. We want to see you here. Follow us on Twitter. You can follow us on Twitch as well. We're everywhere where you are. So we do appreciate it. All right. See you, everybody.
Bye, everyone.
Bye.